Hello, Advanced Math. This is 14.6, the inverse of a square matrix, and we're going to use these to solve systems of equations. Make sure you have your calculator handy as well. There's a few things we'll do by hand, but most of it will be done on the calculator. So first, remember that an inverse will be something that undoes something else and takes it to an identity. Okay? We know inverses with addition, like if I have 5 and I add an opposite of 5. Opposites are inverses because they add to an identity. Reciprocals are multiplicative inverses because they multiply to 1. Okay, you can have functions that are inverses, g of f of x, if they equal x, the identity function. So we also have matrix inverses, or inverse of matrices, and it's denoted a times a to the negative first power. Okay, this right here, this representation, that is referred to as the inverse of matrix A. And if you multiply a matrix times its inverse, you should get this. This is referred to, that's the identity function, or identity matrix. And from last lesson, the identity matrix has 1s going down the main diagonal. Okay? So in the top left, it starts as a 1, and then it goes down in the main diagonal. That's what you want here. Okay? The identity matrix is 1, 0, 0, dot, 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 0, 1, 0, dot, 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 0, 0, 1, dot, 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 so forth and so on. Okay, 1's going down the main diagonal. And notice it is commutative, so it doesn't matter whether you take A times its inverse or its inverse times A. So show that B is the inverse of A, where A is this matrix, B is that matrix. So you're going to multiply them together. And when you do, A times B, you should get the identity. Okay, and this is a 2 by 2 matrix. Okay, and if I take B times A, I got to check it both ways. There are a few instances where it will work one way, but maybe not the other. So check both orders. So A times B and B times A. Okay. This is an example of a square matrix. Remember, a square matrix is you have the same number of rows as columns. Okay, so you have a square matrix, and that's what we're going to have here with the inverses. Okay. So finding the inverse function, it takes you through a lot of work that we're going to use the calculator for. We will go over the formula for a 2 by 2 matrix, but again, you can use your calculator with that if you want. So we're not going to go over that method right there. We'll keep moving. They do use augmented matrices and row operations, which we didn't really cover. They make an augmented matrix with the identity matrix, and they use row operations to convert the left side to make it look like the right side, and this is going to be your inverse over here. Okay. So how we're going to find them. So let's take this one right here. This is a 3 by 3. And we need to input into the calculator. I'm going to put a 3 by 3 matrix into my calculator. I'm just going to make it matrix A. 3 by 3, 1, negative 1, 0, 1, 0, negative 1, 6, negative 2, negative 3. Okay, double check my numbers before I go on. Okay, so I have it. I'm going to go back to my matrix, select matrix A, and then there's that negative 1. Scoot that up for you. There's that x to the negative 1. Okay, that is your inverse button. So I'm just going to push that button right there, and it's going to look like A to the negative 1. Okay. And there you have it. There's your inverse matrix. So negative 2, negative 3, 1, negative 3, negative 3, 1, negative 2, negative 4, 1. There's your inverse matrix. If you want to check it, go back and say, okay, I want to take matrix A times my last answer. So matrix A times my last answer, you should get the identity matrix. I didn't look this up. Let's see if I can store that. If I want to take matrix A, find the inverse, and let's hit this store button right to the left of 1, STO with the arrow. Let's see, I haven't tried this yet. Let's store that into matrix, I'm just going to say matrix C. So I think, let's see if this does. Okay, so if I go back to my matrices, now look, I have a matrix C, and guess what that is? It's my 3 by 3. Okay, so now I can check it. I have it stored in there, so I can say, okay, what's C times A, and that should also be your identity matrix. So that's how you can store a matrix back into another matrix. And I could have done that into B, and it would overwrite the one that we currently have. Okay. So we check, well, does that match what they have? And they said, oh, yep, here's your inverse, -2, -3, 1. The same thing we have here. So that's how you can find a matrix using the calculators. Find the inverse of a matrix on the calculators. This is the 2 by 2 right here. This is page 926. And this is a formula for finding the inverse of a 2 by 2 matrix. Okay, so if it's set up A, B, C, D across the top and then across the bottom, it's 1 over AD minus BC. We're going to learn right here that is something called the determinant. Actually, that part down there is 1 over AD minus BC times this matrix here. Notice the A and the D have switched locations. So A and D switch locations. B and C become their opposites. B and C become their opposites. And you get this down, it does goes a little bit faster than putting it into your calculator. So if they want the inverse of each matrix, so this is A, this is B, this is C, this is D. Okay, this comes from the difference of the cross products. So A times D minus B times C. So what I have is I want this inverse, A inverse, let's get that over, equals 1 over A times D minus B times C. This is going to become a scalar. And I'm going to multiply it by, okay, A and D switch locations, so that becomes a 2. That becomes a 3 down there. And then I have the opposite, so that becomes a positive 1. That becomes a positive 2. So I get 1 over, this is 6 minus 2. 1 over 4 times 2, 1, 2, 3. So 1/4 times 2 would be 2/4, that's 1/2. 1/4 times 1 would be 1/4. 1/4 times 2 is again 1/2. 1/4 times 3 would be 3/4. Okay. Now if you check it, you'll take this times A and A times this, and you should be getting your inverse matrix. So let's see let's check it here. 1/2, 1/4, 1/2, and 3/4. All right, that's good. So on B, when we go through this, B inverse, 1 over, this is A, B, C, D, 1 over 3 times 2 minus -1 times -6. I'm going to multiply that by 2, 1, 6, 3. Now notice what happens on the bottom here is we get 6 minus 6, and that equals 0. So we have 1 over 0 times 2, 1, 6, 3. So if this would happen, that means it is undefined, and there is no inverse. Okay, so B is not invertible, is what they say here. B is not invertible. That's the terminology. Okay, that's why that's called the determinant, that part on the bottom, because it determines whether it has an inverse or not. Okay. On their exploration along the bottom, they ask you to use the graphing calculator, and what message appears on the screen. Do that real quick. Let's edit. So 1, -3, -2, 6. And I want the inverse of matrix B, and what appears is singular matrix. So there's an error, singular matrix. That means that the matrix is not invertible. Okay. Okay, systems of linear equations. So what we have here, we talked about last time writing a matrix equation from a systems. Okay, so they have a system of equations here. Here's their matrix equation. Now, you can solve this using, it's basically your same rules as if I have 3 times x equals 21. Okay, in this case, we divided by 3. That's what we're common with. Divide by 3, we get x equals 7. In matrices, there is no such thing as division. Okay, division takes the form of multiplicating by a reciprocal or an inverse. So if this is 3 times x equals 21, think of it this way. This is a multiplication problem. What is the multiplicative inverse of 3? And that's a fancy way of saying what's the reciprocal. So if I take this side, the reciprocal, the inverse of 3 would be 1/3. And if I multiply it by both sides, I get 1/3 times 3 is 1. I get the identity, equals 21 times 1/3, which is 7. So this is using inverses. Okay, a very fancy way of just dividing by 3. But the same thing applies here. We have a matrix times the variables equals the answer. Coefficients times the variables equals the answer. They are going to find the inverse, this is the key right here, the inverse of A and multiply it by B. So what happens, what we have to do is we can find x, y, and z, and it's going to equal the inverse of the coefficient matrix, 0.06, 0.075, 0.095, 1, 0, -2. We have to take that inverse and then multiply it by 10,000, 730, and 0. Okay, this is a 3 by 3 matrix. This is a 3 by 1 matrix. It has to be in that order. Inverse times the answers. So you have to take the inverse of the coefficients multiplied by the solution. Okay, inverse of the coefficients multiplied by the solution. So here we go. Let's say I gotta put this in. So I have a 3 by 3, 1, 1, 1, 0.06, 0.075, 0.095, 1, 0, -2. There's my first one. Now I go back and I'm going to edit my next one. I need a 3 by 1, 10,000, 730, yeah, 730, 0. Okay, so I'm going to go to my matrices. I'm going to select matrix A, do the inverse times matrix B, all in one step like that. You can just do it like that. You have 4,000, 4,000, 2,000. Okay, and you see that's what they got here. So you'd write your answer as x, y, and z equals 4,000, 4,000, 2,000. That means x is 4,000, y is 4,000, and z is 2,000. Okay, and we can read this problem up here, and this is, they're dealing with savings rates and bonds and interest rates and stuff like that. Okay, you plan to invest $10,000, so x plus y plus z is 10,000. You want an annual return of 730. Okay, the first account earns 6%, second account earns 7.5%, and third account earns 9.5%. You will invest twice as much in AAA bonds as in B bonds, so that's what the third equation comes from. Okay, but for your problems, it will be pretty cut and dry, just the equation. You can write your answer, and want your answer presented in this format right there. Okay. So your questions, 1 and 2 is some vocab. It's either square or inverse matrices. 30, 32, 34, use the matrix capabilities of a graphing utility. Find the inverse matrix if it exists. So use your calculator on these. I took off all the ones that aren't too necessary there. 42 and 44, I want you to try to use that formula on page 926. Okay, these are 2 by 2 matrices. 1 over AD minus BC times D, opposite of B, opposite of C, A. That formula right there. Try to use that formula. Use your calculator to check to make sure you did it right. 52. Now you're going to start solving. It says use the inverse matrix found in exercise 23. Obviously, we didn't do number 23. 23 was wanting you to find it by hand and then calculate this answer by hand. You can use your calculator. Okay? Again, you're going to have your inverse of the coefficient matrix times the solution matrix should equal x, y, and z. Okay? Same thing here. So your answer here should look like x1, x2, x3, x4 equals 1, 2, 3, and 4. Your 4 answers there. Okay, so I'll go through 55, a big old one like this. Okay, 55 and 56, we're just using these. So 55, I need a 5 by 5 matrix. So 1, 2, negative 1, 3, negative 1, 1, negative 3, 1, 2, negative 1, 2, 1, 1, negative 3, 1. Notice I'm not putting the solutions in this. This is not an augmented matrix like we did earlier. Negative 1, 2, 1, negative 1, 2, 1, negative 1, 2, 1. Finding a 5 by 5 matrix without a calculator would take us way too long. 5 by 1, and I want negative 3, 6, 2, negative 3. Okay, so A inverse times B. There's your answers, just like that. We'd say, okay, x1, x2, x3, x4, x5. Don't worry about, if you want to change these variables to x, w, v, w, x, y, and z, that's okay. That'll be easier on your answer part. 0, 1, 2, negative 1, 0. Or I would be okay if you just write them out. x1 equals 0, x2 equals 1. I like the matrices though right now. Okay, so that's what you're doing with the rest of these. If it's not possible to solve some of them, like 70, okay, that means that the inverse matrix does not exist. And let's get my chair up here. And so you just say no solution for that, if that works that way. Okay, so that's it for inverse square matrices. The next one's going to be determinants. Again, that's going to be on our calculator quite a bit. So we're getting close there. Keep up the good work. Keep asking questions when you have them, and I'll see you soon.